Okay, so this is the 2023 Higher Level Maths Junior Cert paper question 7. A, B, C and D are 4 points in the coordinate plane. The points A and B are shown on the coordinate diagram below. Plot and label the points 8, 4 and 3, 6 on the diagram. Okay, so let's do that. So 8, 4 is going to be, we go out 8, we go up 4, so it's going to be here. So this is C. And then D is 3, 6. So that's going to be, you go out 3, you go up 6. That's going to be here. That's D. I'll just put in the coordinates as well. So it's going to be 3, 6 here. And this is 8, 4. Write the coordinates of the points A and B in the space below. The coordinates of the points C and D are already given. So A is just going to be 1, 1. And B then is, you go out 6, you go down 1, so it's 6 minus 1. Pauline wants to prove that ABCD is actually a square. Answer B1 and B2 below to show that ABCD is a square. So the first thing she's going to do is find the distance from A to B and the distance from B to C and show that they're the same. So let's do that anyway. So the distance formula here that we're going to use is the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. That's in your tables. So you've just got to label the points. We want, let's see, we want A, B. So I'm going to say x1, y1, x2, y2. And I'm just going to stick those into the formula. So we want the distance from A to B. So it's going to be the square root of x2, which is 6, minus x1, which is 1 squared, plus minus 1 squared. That gives me 6 minus 1 is 5, and 5 squared, 25. Minus 1 is minus 2. When you square minus 2, you get plus 4. So we get the square root of 29. Now if we do the distance from B to C then, so it's going to be x2, so I'm going to say 8 minus 6 to be squared plus 4 minus 1 to be squared. So that's going to give me 8 minus 6 is 2, 2 is 4. 4 minus 1 is 4 plus 1, which is 5. 5 squared, 25. And we also get the square root of 29. Therefore, AB is equal to the distance AB is equal to distance BC. That's all we had to do there. Next one, without measuring the diagram, show that AB is perpendicular to BC. So AB, so A is 1, 1. I'm just going to write these down. A is 1, 1. We want B as well. So B is 6 minus 1. And we also want C. C is 8, 4. So we want to show that AB is perpendicular to BC. So we need to look at slopes here. So we want the slope of AB first of all. That's going to be, the formula again is in your log tables. It's y2 minus y1, x2 minus x1 here. So I'm going to say y2 is going to be this one here, and this is y1. So it's going to be minus 1 over x2 minus x1, which is 6 minus 1. So that gives me minus 2 over 5. Now the slope then of BC, same thing again. This is y2, this is y1, so it's going to be 4 minus 1, and then 8 minus 6. So 4 minus 1 is 4 plus 1, which is 5. 8 minus 6, 2. So what you would need to do is multiply these two slopes. So you would say minus 2 over 5 multiplied by 5 over 2. Top by top, bottom by bottom. So it's going to be minus anyway because it's minus times plus. 2 times 5, 10. 5 times 2, 10. So that's minus 1. Therefore, AB is perpendicular to BC. And that's it really for that one. Next one. Kieran makes the following statement. So the statement is every parallelogram is a square. Is Kieran's statement true or false? Justify your answer. So it's going to be false anyway. Really all you've got to do here is just give one counter example. So to justify it then, for example, so we can draw a parallelogram here, or a rough sketch of a parallelogram anyway. Say like this, where this is parallel to this one is parallel to this one here. Now we can just stick in the angles here. You can say that this is 40 degrees, so that means this must be 40 degrees here. That would make this one 140 degrees and this one here 140 degrees. So this is a parallelogram, but not a square, since the angles are not 90 degrees and all the sides are not equal. Okay, write down the converse of Kieran's statement. So Kieran's statement is that every parallelogram is a square, so the converse would be every square is a parallelogram. And that's it for this question.